So let's continue with the different types of oil traps. The two major groups is the stratigraphic and the structural. And this slide shows you the stratigraphic, the most typical stratigraphic trap. Let's imagine an area where you got a river with sandbars and channel deposits surrounded by the floodplain, and on the floodplain you mostly have clay-sized sediment. The clay-sized sediment actually will act as an impermeable layer, which means if any oil forms in the impermeable layers, it will be actually migrating into the more porous sandstone, which is usually the channel sediment. So when the oil is forming and it's trying to migrate, it won't be able to go anywhere because these are all impermeable rocks. So basically the oil is trapped in any kind of river channel sediment, just like here. Like river channel, river channel, river channel. If you go back in time, because this here shows the going back in time. And as the river is moving back and forth on its own floodplain, if you go down, you will find different channel deposits with possibly oil in them at different levels and different areas. So that's one type of stratigraphic trap. And on this one, where you can see like 4 different kind of stratigraphic trap, this is the one which I just talked about, which relates to the river channel sediments. This is when you have a sandstone and surrounded by shale, and if the shale is a source rock, as the oil starts to try to migrate, it cannot really go much anywhere but into these sand deposits, and then it gets trapped right here because the sand deposit is being pinched out, so it's just thinning away and it seizes as a sedimentary rock in this sequence right here. This here is when you have an unconformity, and above the unconformity, this is all impermeable layer, and below the unconformity there is a permeable which oil is migrating in, and it migrates up and it cannot go any further because there is this so-called cap rock or impermeable layer. In this situation, we have coral reefs, and the same thing, surrounded by impermeable rocks, and the oil has become trapped in the more porous and permeable rocks, and it's trapped by having clays and impermeable layers around it. The other major type is the so-called structural traps. The first kind is when you have a fault line. Right here you have a fault line, and the permeable layers are faulted the way that they are opposed now to an impermeable layer. So right there the oil is getting trapped. So that's a good place to find oil. Like if you find a fault line and you have a good chance to find oil. The other kind is the anticline. When you have a permeable layer or reservoir rock in this case, and it is actually capped by impermeable layers, then of course as the oil migrating, it goes up, but then it cannot go anywhere because it's impermeable layers, so it's gonna get trapped. And this here is the salt dome. I already have kind of talked about it, that when you do have a salt deposit, as time goes on, the salt is much lighter than all the surrounding sediment, so the salt actually starts to come up through the sediment, causing like anticline fault formations. And because the salt itself is impermeable, if there is any oil migration against the salt dome, it's going to be trapped right there because the salt is impermeable. And in the Gulf of Mexico, we actually have a whole lot of salt domes. So you can see that a lot of the oil traps in the Gulf of Mexico are related to salt dome tectonics. Okay, so how do we find the oil? The first thing which scientists do, and it's relatively cheap, you know, running a seismic survey is definitely not very, very cheap, but much cheaper than drilling an oil well, not knowing where to drill it. So what we do, what seismologists or geophysicists are doing, they have two tracks going after each other. One is the vibrating track, and that is what generates the seismic waves, and the other one is the recording the recording track. The recording track has geophones, and the geophones are actually recording the small scale earthquakes the vibrating track generates. What happening that as the vibration goes down to the earth, whenever it reaches a density difference or a boundary between two rock layers with different densities, actually the vibration, the energy which goes through the vibration is actually changing speed, and some of it will refract back to the surface, right to the geophones. So at the end, you're gonna get a seismic cross section just like that. And actually, the seismic cross sections are showing the different structures, the different density rocks, and how they layered. It's really powerful, because when you look at the seismic profile, you actually can see where you have anticline structures or fault line structures or salt dome tectonics. Actually, you can see that also. Today, the geophysics are amazing. They actually can do 3D seismic profiles. So as you can see on the left, that's a beautiful anticline structure, and on the right, those are like fault line structures. So it is actually making it much easier to find places where to drill. So when you did find these structures, then they tried to put, like, if it's in the ocean, they put a rig, and then from the rig they can drill wells. And today they can actually drill wells like horizontally, basically in any angle. From one well they can do like as many as they want with different angles, even horizontal. They can drill horizontally. If it's dry land, it's a bit easier because you don't have to deal with the ocean. Now, most of the time, you probably would think that the oil, because it's lighter, will just come up and you get all of it. But in real life, most of the oil people can take out is 50 to 60% of the capacity down there. So you're not gonna get 100% of the oil. You only get like half of it. So people try to come up with different methods to try to get more oil out of the ground. One of the possibilities, when they put a water well and they push down hot water, and the hot water warms up the whole area, and remember, anything higher the temperature, lower the density. So by heating up the area, basically the density of the oil goes down because it's warmer, so therefore it's easily coming up. So it's easier for it to come up, so therefore you can get more than 50 to 60% out from the soil. Okay, so I hope you do understand a little bit of the formation, the discovery, and the getting out of the oil from the ground. Now let's talk about the distribution of the world petroleum reserves. I guess you all know that all the way until a couple of years ago, this is how the distribution looked like. Most of the oil reserves are in the Middle East, and there was a little bit around South America, some in Russia, of course. North America had some. Now this strictly changed lately by discovering new oil reserves, but also because of the oil, the fracking. I don't know if you've heard about the black shale fracking. What happens here? They figured out that if not all the source rock have had all the oil migrate out of it, or gas. Some of them just couldn't get out. So therefore, there is a way that today they can make it economic to get the oil out from the source rock, which hasn't come out. This is what they call the oil fracking. And actually today, more and more location, they can get a whole lot of oil out, oil or gas, mostly gas. And this map shows the shale gas or shale oil industry in the USA. So you can see that there is a whole lot of area where they can get a huge amount of gas out. So therefore, this really changes the oil reserve or gas reserve map of the world, because United States is basically one of the leading country in, if you count the oil reserves. So this really can change the future of our economy if you think about it, because suddenly we don't depend that much on the Middle East, but we can get actually energy right here. So there is no transportation cost. The price is not moving up and down all the time. So this is like a very, very important futuristic uh, thing for North America. And of course, you have all heard about how many bad things happens around oil fracking. For example, the ones happening in Pennsylvania, the oil layer is not very far away from the groundwater. So when they do the fracking, basically they can contaminate the groundwater. So there is a lot of technology which has to come around so they can absolutely separate the two. And we have to see that there is a lot of areas in the US where actually the groundwater level is not close to where the black shale is located. So we do have to do something about the oil fracking if you think about it, because the consumption of the oil is like that. So you can see how much North America depends on the oil. And I don't know how many people in the near future will say, I don't want a car, I just want public transportation. I don't care for driving my own car. And I don't mind getting those itty bitty tiny cars, or I'll have a Prius. It doesn't matter that it's not 4-wheel drive. So most people do want the way they have been. So it's a very good thing that the shale fracking or shale gas fracking is bringing a lot of relatively cheap local energy to the United States. Okay, so this was this part, and I'll see you in the next part.